Humanity's dream of venturing beyond our solar system, once the stuff of science fiction, is edging closer to reality. What if the tools to explore distant stars and unlock the secrets of the cosmos were already being developed? Today, we're diving into 20 groundbreaking technologies that could transform space exploration as we know it. From propulsion systems that defy our current limits to habitats capable of sustaining life in the harshest environments, these innovations are redefining what's possible. Together, we'll explore how these advancements could take us to the stars, not as distant points of light, but as reachable destinations. The future of space travel is here, and it's more exciting than ever. Let's uncover the technologies that will propel us into this new frontier. Picture this, a spacecraft drifting through the vast expanse of space, propelled not by roaring engines or burning fuel, but by the gentle push of sunlight. This isn't science fiction, it's the promise of LightSail Propulsion, a breakthrough technology that could redefine how we explore the universe. By harnessing the power of solar photons, LightSail systems use enormous reflective sails to capture the sun's energy, creating thrust that can carry spacecraft across unimaginable distances. What makes this technology so revolutionary? For starters, it eliminates the need for traditional fuel altogether. Instead of relying on heavy, expensive propulsion systems, light sails offer a lightweight, cost-effective solution that could make interstellar travel more accessible than ever before. The concept isn't entirely new. Scientists have been experimenting with solar sails for decades, but recent advancements have brought this idea closer to reality. One of the most exciting possibilities, missions to nearby star systems like Alpha Centauri, which lies just over 4 light-years away. With traditional propulsion methods, such a journey would take tens of thousands of years. But with light sail technology, experts believe we could cut that time down to a matter of centuries, or even less as the technology evolves. Imagine the implications: humanity's first interstellar probes gliding silently through the cosmos, powered by the sun's endless energy. It's a vision that could transform our understanding of space and our place within it. What's truly remarkable about light sail propulsion is its simplicity. Unlike complex, fuel-dependent engines, solar sails operate on a straightforward principle. Photons from the sun exert a tiny but continuous force when they strike a reflective surface. Over time, this force builds up, allowing a spacecraft to reach incredible speeds without the need for additional fuel. This not only reduces the cost of space missions, but also opens up new possibilities for long-term exploration. Probes equipped with light sails could travel farther and faster than ever before, gathering data from distant stars, planets, and beyond. And because they don't rely on finite fuel supplies, these spacecraft could continue their journeys indefinitely, expanding the frontiers of human knowledge. Critics might argue that light sail propulsion has its limitations. After all, sunlight grows weaker as a spacecraft moves farther from the sun, but even this challenge is being addressed. Researchers are exploring ways to enhance the efficiency of solar sails, such as using lasers to provide additional thrust. These innovations could extend the reach of light sail technology, making it viable for missions to even the most remote corners of the galaxy. The potential is staggering, a future where interstellar travel is not just a dream, but a tangible goal within our grasp. As we stand on the brink of this new era in space exploration, one thing is clear: light sail propulsion represents a bold step forward. It's a technology that challenges our assumptions about how we move through space and opens up possibilities that were once thought impossible. The idea of spacecraft sailing on beams of light might sound like something out of a futuristic novel, but it's a vision that's rapidly becoming a reality. And as we continue to push the boundaries of what's possible, the stars may no longer be out of reach. Imagine a rocket that doesn't rely on burning fuel, but instead taps into the same process that powers the sun. That's the promise of fusion rockets, a groundbreaking technology that could redefine how we explore the cosmos. Unlike traditional chemical propulsion, which burns fuel for thrust, fusion rockets harness the energy released when atomic nuclei fuse together. This process generates exponentially more power, enabling spacecraft to reach speeds that were once thought impossible. One of the biggest challenges of interstellar travel is the sheer amount of time it takes to reach even the closest stars. With current technology, a trip to Proxima Centauri, our nearest stellar neighbor, would take tens of thousands of years. Fusion rockets could slash that time dramatically, potentially cutting it down to just decades or even less. By achieving velocities far beyond what chemical rockets can offer, these engines open the door to missions that were previously unimaginable. The science behind fusion rockets is rooted in the same principles that fuel stars. When hydrogen atoms fuse to form helium, they release an incredible amount of energy. Harnessing this reaction on Earth has been a long-time goal, and while we've made strides in fusion energy for power generation, adapting it for space travel presents a unique set of challenges. Scientists are working to create compact, efficient reactors that can withstand the rigors of space while producing enough thrust to propel a spacecraft across vast distances. Prototypes are already in development, with researchers experimenting with different designs to optimize performance. One promising approach uses magnetic fields to contain the fusion reaction, ensuring stability and control. Another involves using lasers to ignite the fuel, creating a controlled burst of energy. These innovations are bringing us closer to a future where fusion rockets could become a reality. The potential benefits are staggering. Faster travel times mean more efficient missions and the ability to explore distant star systems within a human lifetime. Fusion rockets could also reduce the need for enormous fuel reserves, making spacecraft lighter and more agile. This technology doesn't just promise to take us to the stars, it could make interstellar travel practical and sustainable. As we continue to push the boundaries of what's possible, fusion rockets stand as a testament to human ingenuity. They represent a bold step toward turning science fiction into science fact, bringing us closer to the dream of exploring the universe beyond our solar system. The stars are calling, and with fusion rockets, we may soon have the means to answer. One of the most critical hurdles for long-term space travel is the toll it takes on the human body. In the weightlessness of space, muscles weaken, bones lose density, and the cardiovascular system struggles to function as it does on Earth. Without a solution, these health risks could make extended missions, let alone journeys to distant stars, nearly impossible. Enter artificial gravity, a groundbreaking technology designed to counteract these effects by replicating the gravitational pull we experience on our home planet. The concept hinges on the principle of centrifugal force. Imagine a spinning habitat like a massive cylindrical space station rotating at a controlled speed. As it turns, the force generated pushes objects outward, mimicking gravity. Astronauts inside would feel a downward pull, allowing them to walk, exercise, and live much as they would on Earth. This isn't just science fiction. Engineers and scientists have been exploring designs for rotating space habitats for decades, and recent advancements are bringing these ideas closer to reality. But why is artificial gravity so essential? For starters, it addresses the health risks that come with prolonged exposure to microgravity. Beyond that, it creates a more stable and familiar environment for astronauts, reducing the psychological strain of living in space for years or even decades. Whether we're talking about missions to Mars or voyages to other star systems, artificial gravity could be the key to keeping crews healthy, focused, and ready to tackle the challenges of exploration. This technology isn't just a luxury, it's a necessity. Without it, the dream of interplanetary or interstellar travel remains out of reach. By solving one of the most pressing issues of long-term spaceflight, artificial gravity could pave the way for humanity's next giant leap into the cosmos. Picture this: you're hurtling through the vacuum of space, millions of miles from Earth, when suddenly a tiny crack forms in your spacecraft's hull. In the unforgiving environment of space, even the smallest damage can spell disaster. But what if your ship could heal itself? Enter self-healing materials, a revolutionary technology that's changing the game for space exploration. These materials are designed to detect and repair damage automatically, using advanced polymers or microcapsules filled with healing agents. When a crack or break occurs, these agents are released, sealing the damage and restoring structural integrity. No need for astronauts to perform risky repairs or carry spare parts. This technology ensures that spacecraft can withstand the rigors of long-term missions with minimal maintenance. The potential of self-healing materials goes beyond just fixing cracks. They can also enhance the durability of critical components, from solar panels to fuel tanks, which are constantly exposed to micrometeoroid impacts and extreme temperatures. By reducing the risk of catastrophic failures, these materials make space travel safer and more reliable. And it's not just about survival. Self-healing technology could extend the lifespan of spacecraft, making ambitious missions to Mars or even distant star systems more feasible. What makes this innovation even more exciting is its versatility. While it's currently being developed for space applications, self-healing materials could have far-reaching implications here on Earth. Imagine bridges that repair themselves after an earthquake, or smartphone screens that fix their own scratches. The possibilities are endless. For space travel, though, self-healing materials are more than just a convenience, they're a necessity. As we push the boundaries of human exploration, technologies like these will be the backbone of our journey to the stars. As we journey farther into the cosmos, one of the most pressing challenges becomes clear: how do we stay connected across unimaginable distances? Traditional communication methods like radio waves face significant limitations when spanning the vastness of space. Enter quantum communication, a revolutionary technology that could transform how we transmit information across the stars. At its core, quantum communication relies on a phenomenon known as quantum entanglement, where particles become linked in such a way that the state of one instantly influences the other, no matter how far apart they are. This means data can be transferred instantaneously and with unparalleled security, making it a game-changer for interstellar exploration. Imagine a future where astronauts on distant worlds can communicate with Earth in real time without the frustrating delays of light speed limitations. Quantum communication doesn't just solve the problem of distance, it ensures that our messages are tamper-proof and secure, safeguarding critical information as we push the boundaries of human exploration. This breakthrough isn't just about staying in touch, it's about building a bridge between worlds, enabling humanity to remain united even as we spread across the galaxy. With quantum communication, the stars feel a little closer, and the possibilities for connection become truly limitless. Imagine a beam of light so precise and powerful that it could push a spacecraft through the vastness of space without the need for traditional fuel. This isn't science fiction, it's the promise of space-based lasers, a groundbreaking technology that's redefining how we think about exploration. Lasers, once confined to labs and sci-fi stories, are now emerging as a versatile tool in our cosmic toolkit, capable of transforming propulsion, communication, and even our understanding of the universe itself. One of the most exciting applications of space-based lasers is their potential for propulsion. Unlike conventional rockets that rely on chemical fuels, laser propulsion works by directing intense beams of light at specially designed spacecraft sails. These sails, often made of ultra-thin reflective materials, harness the energy of the laser to generate thrust without the need for onboard fuel. The result: a lighter, faster, and more efficient way to travel through space. This method, known as laser sail propulsion, could drastically reduce the time it takes to reach distant planets or even neighboring star systems, opening up new frontiers for exploration. But lasers aren't just about getting us there, they're also about staying connected once we've arrived. In the vast emptiness of space, traditional communication methods like radio waves can be slow and inefficient, especially over interstellar distances. Space-based lasers offer a solution by transmitting data at the speed of light. With their ability to carry vast amounts of information across immense distances, they could revolutionize how we communicate with probes, rovers, and even future colonies on other worlds. Imagine receiving high-definition images from a distant exoplanet or sending real-time instructions to a spacecraft light years away, all made possible by the precision of laser communication. The implications of this technology extend far beyond our solar system. Space-based lasers could be the key to unlocking the mysteries of the universe, enabling us to explore regions of space that were once thought unreachable. By combining their propulsion and communication capabilities, they offer a clean, efficient, and scalable solution for future missions, whether we're aiming to study nearby asteroids or venture into the unknown reaches of the galaxy. The power of lasers isn't just illuminating the darkness of space, it's lighting the way toward a future of limitless discovery. Picture this: tiny robots, so small they're invisible to the naked eye, capable of repairing a spacecraft or analyzing alien soil. This isn't science fiction, it's the promise of nanotechnology. At its core, nanotechnology is all about working with materials at the atomic and molecular scale, unlocking possibilities that were once unimaginable. In the realm of space exploration, this technology is poised to revolutionize how we build, maintain, and even think about missions beyond our planet. One of the most exciting applications is in the development of advanced materials. Imagine spacecraft constructed from nanomaterials, ultra-lightweight yet incredibly strong. These materials could drastically reduce the weight of rockets, making launches more efficient and cost-effective. But it doesn't stop there. These same materials could be used to create structures that withstand the harsh conditions of space, from extreme temperatures to radiation exposure. It's like giving our spacecraft a super-powered suit of armor. Then there's the potential of nanobots. These microscopic machines could be deployed to perform tasks that are too dangerous or difficult for humans or even traditional robots. Need to repair a damaged solar panel or inspect a hard-to-reach part of a space station? Nanobots could handle it with precision and ease. They could even conduct scientific experiments in environments too hostile for astronauts, opening up new frontiers of discovery. What makes nanotechnology truly game-changing is its ability to enhance the efficiency of space missions. By reducing the need for bulky equipment and manual labor, it allows us to focus on the bigger picture, exploring further and learning more about the universe. It's a small-scale innovation with the potential to make a giant leap for humanity, proving that sometimes the tiniest tools can achieve the grandest goals. Artificial intelligence is revolutionizing how we explore the cosmos, acting as an indispensable partner in our journey to the stars. Think about it: space missions generate mountains of data, from high-resolution images of distant planets to intricate readings of cosmic radiation. Advanced AI systems excel at sifting through this information, identifying patterns, and drawing insights that would take humans years to uncover. This capability not only speeds up discoveries but also ensures that nothing vital slips through the cracks. One of the most impressive feats of AI in space is its ability to operate autonomously. When a spacecraft is millions of miles from Earth, waiting for human instructions isn't practical. AI steps in, making real-time decisions to navigate, adjust trajectories, and even troubleshoot technical issues. This level of independence is crucial for missions to distant worlds where communication delays can stretch to hours or even days. But AI's role doesn't stop there. It's also paving the way for more ambitious projects. By reducing the need for constant human oversight, these systems allow us to tackle missions that were once deemed too risky or complex. Whether it's landing on volatile asteroid surfaces or exploring the icy moons of Jupiter, AI is the silent force making these daring ventures possible. As we look to the future, it's clear that AI will be the guiding intelligence behind humanity's push into the stars. It's not just a tool, it's a collaborator, helping us unlock the mysteries of the universe in ways we've only begun to imagine. The next frontier of space exploration isn't just about reaching new destinations. It's about doing so with the precision and ingenuity that only advanced AI can provide. What if astronauts could create whatever they needed right there in space? That's exactly what 3D printing technology is making possible. This groundbreaking innovation allows us to manufacture tools, spare parts, and even entire habitats without relying on shipments from Earth. By using materials already available in space or even recycling old components, 3D printing is paving the way for a new era of self-sufficiency in space exploration. Imagine a scenario where a critical piece of equipment breaks during a mission. Instead of waiting months for a replacement to arrive, astronauts can simply print a new one on the spot. This capability not only saves time but also drastically reduces the cost and complexity of resupply missions. It's like having a cosmic workshop at your fingertips, ready to tackle any challenge that arises. But 3D printing isn't just about fixing things, it's about building them too. Researchers are exploring ways to print entire habitable structures using lunar or Martian regolith, the loose soil found on these celestial bodies. This means future explorers could construct their own shelters using resources from their environment, eliminating the need to transport bulky building materials from Earth. It's a game-changer for long-term missions, making the dream of establishing colonies on other planets more achievable than ever. The sustainability aspect of 3D printing is equally impressive. By recycling materials already in space, we can minimize waste and reduce the environmental impact of space exploration. This closed-loop system aligns perfectly with the principles of resource efficiency, ensuring that missions can sustain themselves over extended periods without constant resupply. As 3D printing technology continues to advance, the possibilities are virtually limitless. From creating intricate medical devices to assembling large-scale infrastructure, this innovation is transforming the way we live and work beyond Earth. It's not just a tool, it's a cornerstone of humanity's journey into the cosmos. As we venture further into the cosmos, one of the most fascinating and potentially game-changing technologies on the horizon is cryonics. Picture this, a spacecraft hurtling through the void of space, its crew safely preserved in a state of suspended animation, their bodies and minds shielded from the rigors of an interstellar voyage. Cryonics, the science of preserving living organisms at ultra-low temperatures, offers a solution to one of space exploration's greatest challenges: time. The vast distances between stars mean that even the fastest spacecraft would take decades, if not centuries, to reach their destinations. For human crews, this presents not just physical but also psychological hurdles, from the risks of prolonged exposure to space radiation to the mental strain of isolation. Cryonics proposes a bold workaround. By placing astronauts into a state of deep hibernation, their metabolic processes slow to a near halt, effectively pausing the biological clock. This could allow crews to endure the long stretches of interstellar travel without aging or experiencing the wear and tear of life in space. While the technology is still in its infancy, with significant hurdles like perfecting the freezing and revival processes, the potential is staggering. Imagine the moment of awakening on a distant world, the crew refreshed and ready to step onto an alien landscape, their journey through the stars nothing more than a dream. For now, Cryonics remains a vision of the future, but it's one that could redefine what it means to explore the universe. Now, let's shift our focus to a concept that sounds like it's straight out of science fiction, but is inching closer to reality: space elevators. Picture this: instead of relying on the thunderous roar of rockets to break free from Earth's gravity, what if we could simply take an elevator ride into space? This isn't just a wild idea, it's a theoretical structure that could fundamentally change how we access the cosmos. At its core, a space elevator is anchored to the Earth's surface, likely near the equator, and extends all the way into space, tethered to a counterweight in orbit. Think of it as a massive, ultra-strong cable connecting our planet to the stars. The concept hinges on using this tether to transport materials, equipment, and even people up and down, eliminating the need for traditional rockets. And here's the kicker: it's not just about convenience. Space elevators could drastically reduce the cost of reaching orbit, making space travel more accessible than ever before. But how would this actually work? The key lies in the counterweight, which keeps the tether taut and stable. Imagine a bowling ball tied to the end of a string. When you spin it around, the ball pulls the string outward. In the same way, the counterweight in orbit would keep the tether stretched, creating a reliable path for cargo and passengers. This setup could make trips to space as routine as taking a train to the next city. Of course, there are challenges to overcome. Building a tether strong enough to withstand the immense forces involved is no small task. Materials like carbon nanotubes are being explored for their incredible strength-to-weight ratio, but we're not quite there yet. Still, the progress is promising, and the potential rewards are enormous. Space elevators could open up new opportunities for industries like manufacturing, research, and tourism, all while reducing the environmental impact of space travel. This vision is more than just a game changer. It's a glimpse into a future where space is no longer the exclusive domain of rocket scientists and astronauts. It's a future where anyone with a dream of exploring the stars could realistically take that first step. And while we're not quite ready to press the button for the cosmic penthouse, the idea of space elevators is no longer confined to the pages of sci-fi novels. It's a tangible possibility that's slowly but surely climbing toward reality. Imagine stepping onto a barren, lifeless planet and over time transforming it into a thriving world teeming with forests, rivers, and breathable air. This is the audacious promise of Terraforming Technologies, a concept that sounds like science fiction but is rooted in serious scientific research. At its core, terraforming is about making planets habitable for humans by altering their environments to mimic Earth's conditions. It's a monumental task, but one that could unlock the potential for humanity to establish permanent colonies beyond our home planet. The process begins with the atmosphere. On planets like Mars, where the air is thin and mostly carbon dioxide, terraforming would involve releasing gases to thicken the atmosphere and trap heat, creating a greenhouse effect. This could warm the planet's surface, melting frozen water and potentially creating lakes and rivers. Over time, microorganisms and plants could be introduced to produce oxygen, slowly making the air breathable. But it's not just about air and water. Terraforming also requires building ecosystems from scratch, introducing species that can thrive in these new conditions and creating a sustainable balance. Of course, the challenges are immense. Terraforming a planet could take centuries, if not millennia, and would require technologies we're only beginning to develop. Yet, the rewards are equally staggering. Colonizing other planets could ensure the survival of humanity in the face of Earth's environmental challenges or cosmic threats like asteroid impact. It's a vision that pushes the boundaries of what we think is possible, blending science, engineering, and imagination to redefine humanity's place in the cosmos. While we're still far from turning this dream into reality, the groundwork is already being laid. Scientists are studying how to produce oxygen on Mars, how to melt polar ice caps, and how to introduce life to barren soils. Each discovery brings us one step closer to a future where humans might walk on alien worlds that feel like home. Terraforming isn't just about survival, it's about expanding the horizons of possibility and creating new worlds where humanity can thrive. As we venture further into the cosmos, interstellar drones emerge as the ultimate pioneers of exploration. These autonomous spacecraft are designed to journey beyond our solar system, traveling unimaginable distances to reach distant star systems. Unlike traditional probes, interstellar drones operate independently, making decisions in real time as they navigate the vast expanse of space. Their primary mission is to gather data, conduct experiments, and map uncharted territories, tasks that would take humans centuries to accomplish. Imagine a fleet of these advanced drones, each equipped with cutting-edge sensors and instruments, venturing into the unknown. They can analyze the composition of alien atmospheres, detect signs of water, or even search for traces of life on distant exoplanets. The data they collect is transmitted back to Earth, providing scientists with invaluable insights into the mysteries of the universe. This information not only deepens our understanding of the cosmos, but also lays the groundwork for future human exploration. What makes interstellar drones truly remarkable is their ability to adapt to unforeseen challenges. Built to withstand extreme conditions, they can endure the harsh environments of space, from intense radiation to the chilling vacuum of interstellar voids. Their autonomous systems allow them to adjust their trajectories, troubleshoot technical issues, and prioritize scientific objectives, all without human intervention. These drones are more than just machines. They are the scouts of the future, blazing a trail for humanity to follow. By exploring distant star systems, they help us identify potential destinations for human missions, ensuring that when we finally take that giant leap, we do so with confidence and knowledge. The era of interstellar drones is not just about discovery, it's about preparing for the next chapter in our cosmic journey. As we venture further into the cosmos, the dangers lurking in space become increasingly apparent. One of the greatest threats to interstellar travel, radiation and debris. That's where plasma shields come into play, a revolutionary technology designed to protect spacecraft and their crew from the harsh realities of deep space. Picture this, a magnetic field generated by superheated plasma, acting as an invisible force field around the vessel. It's not just a barrier, it's a lifeline for astronauts on long missions, shielding them from harmful cosmic rays and micrometeoroids that could otherwise spell disaster. The science behind plasma shields is as fascinating as it is vital. By ionizing gas to create plasma, these systems produce a magnetic field capable of deflecting charged particles. This isn't just about avoiding damage to the spacecraft, it's about safeguarding human health. Prolonged exposure to space radiation can lead to severe health issues, from cancer to neurological damage. Plasma shields act as a protective envelope, ensuring that astronauts remain safe even in the most hostile environments. Imagine a voyage to Mars or beyond, where the risks multiply with distance. Without this technology, such missions would be nearly impossible. But plasma shields aren't just about survival, they're about exploration. As we look to the stars, these shields become the guardians of our ambitions, enabling us to push the boundaries of what's possible. They're a testament to human ingenuity, turning the challenges of space travel into opportunities for discovery. With plasma shields, the dream of interstellar travel isn't just a distant fantasy. it's a tangible goal, one step closer to reality. As we venture further into the cosmos, one of the most pressing challenges becomes how to power our spacecraft efficiently and sustainably. Enter energy harvesting in space, a groundbreaking technology that taps into the vast, untapped energy sources available in the universe. At its core, energy harvesting captures and converts natural cosmic resources like solar radiation or even cosmic rays into usable power for spacecraft and other technologies. This isn't just about saving fuel, it's about rethinking how we approach energy in the most remote reaches of space. Picture this, a spacecraft gliding through the void, not weighed down by bulky fuel tanks, but instead drawing energy directly from the sun or other cosmic phenomena. This is the promise of energy harvesting. Solar radiation, for instance, is abundant and virtually limitless in space, making it an ideal power source. But the innovation doesn't stop there. Cosmic rays, high-energy particles traveling through space, also hold potential for energy capture. These technologies aren't just theoretical, they're already being explored and tested, offering a glimpse into a future where our spacecraft are powered by the very environment they travel through. What makes energy harvesting so transformative is its ability to extend the lifespan of missions. Traditional fuel sources are finite, limiting how far and how long we can explore. But with energy harvesting, spacecraft could operate for years, even decades, without the need for refueling. This could revolutionize deep space missions, enabling us to reach destinations previously thought impossible. And let's not forget the environmental impact. Energy harvesting is inherently renewable, reducing our reliance on non-renewable resources and minimizing the ecological footprint of space exploration. It's a step toward a more sustainable future, not just for Earth, but for the entire solar system and beyond. The implications are profound. From powering satellites to enabling interstellar travel, energy harvesting could fundamentally change how we explore and interact with the universe. It's a technology that doesn't just solve a problem, it opens the door to entirely new possibilities. Imagine being an astronaut tasked with constructing a habitat on the surface of the moon or repairing equipment in the weightless void of space. These environments demand immense physical effort, but what if there was a way to enhance human strength and endurance to meet these challenges head-on? Enter exoskeletons, wearable robotic devices designed to amplify the capabilities of astronauts, making them more efficient and resilient in the most demanding conditions. Think of exoskeletons as a second skin, a mechanical suit that works in harmony with the human body. They provide additional strength to lift heavy objects, reduce fatigue during prolonged tasks, and even counteract the effects of microgravity on muscles and bones. In essence, these devices transform astronauts into superhumans, capable of performing feats that would otherwise be impossible. For example, building a lunar base or assembling a space station becomes less about physical limitation and more about human ingenuity and skill. But it's not just about raw power. Exoskeletons are engineered with precision to ensure safety and comfort. They incorporate advanced sensors and actuators that respond to the wearer's movements, offering support exactly where and when it's needed. This level of integration minimizes the risk of injury and maximizes productivity, allowing astronauts to focus on their missions rather than their physical strain. What makes this technology truly revolutionary is its potential to extend human reach in space exploration. Whether it's traversing rugged Martian terrain or conducting repairs in the vacuum of space, exoskeletons empower astronauts to push boundaries like never before. They're not just tools, they're enablers of discovery, opening up new possibilities for what humans can achieve beyond Earth. As we look to the future, exoskeletons will undoubtedly play a pivotal role in long-duration missions and the establishment of extraterrestrial colonies. They bridge the gap between human potential and the challenges of space, ensuring that when we venture further into the cosmos, we're not just surviving, we're thriving. Imagine sending a message to someone on Mars and having it arrive almost instantly. That's the promise of the 17th breakthrough technology on our list, the Interplanetary Internet. This isn't just a futuristic concept, it's a necessity for the next era of space exploration. At its core, the Interplanetary Internet is a network designed to connect Earth with distant planets, spacecraft, and even future colonies. It's the backbone of communication that allows us to share data, coordinate missions, and stay connected across the vastness of space. So, how does it work? Unlike Earth's internet, which relies on fiber optics and satellites in close proximity, the interplanetary internet has to overcome immense distances and delays. It uses a series of relay nodes, think of them as cosmic switchboards, that bounce signals between planets and spacecraft. These nodes ensure that data can travel reliably, even when a planet is on the opposite side of the Sun or millions of miles away. One of the key innovations here is something called the Delay-Tolerant Network, or DTN. This system stores and forwards data whenever a connection is available, rather than relying on a constant, uninterrupted link. It's a bit like sending a letter instead of making a phone call, but it's incredibly effective for the challenges of space. The implications of this technology are staggering. For astronauts on long missions, the interplanetary internet means access to real-time data, whether it's scientific findings from Earth or even video calls with loved ones. For spacecraft, it ensures seamless communication with mission control, allowing for precise navigation and troubleshooting. And for future colonies, it's the lifeline that keeps them connected to humanity's collective knowledge and resources. But the interplanetary internet isn't just about practicality, it's about unity. It's a symbol of how technology can bridge the gap between worlds, bringing us closer together even as we venture farther apart. As we look to the stars, this network will be the thread that ties our ambitions to reality, making the dream of exploring the cosmos a shared, connected journey. But what if the key to unlocking the stars lies within us, within our very DNA? Genetic engineering is emerging as a game-changer in space exploration, offering solutions to some of the most daunting challenges humans face beyond Earth. Imagine astronauts whose bodies are naturally equipped to withstand the intense radiation of deep space or the muscle and bone loss caused by prolonged exposure to low gravity. These aren't scenes from science fiction, they're possibilities being actively explored by scientists today. By modifying specific genes, researchers aim to enhance human resilience, creating a new generation of spacefarers who are biologically optimized for the cosmos. But the potential of genetic engineering doesn't stop there. One of the biggest hurdles to long-term space missions is the ability to sustain life in alien environments. How do you grow food on a barren planet or a spacecraft with limited resources? The answer might lie in genetically engineered plants tailored to thrive in extraterrestrial conditions. Scientists are already experimenting with modifying crops to grow in soil with low nutrients, withstand extreme temperatures, and even resist the harmful effects of space radiation. This could pave the way for self-sustaining colonies on the Moon, Mars, or beyond, ensuring that future explorers have the resources they need to survive and thrive. Genetic engineering also opens the door to innovations like bioengineered microorganisms that could help terraform inhospitable planets, making them more Earth-like over time. These advancements are not just about solving immediate problems, they're about redefining what's possible for humanity's future in space. By harnessing the power of biology, we're not just preparing to visit the stars, we're preparing to live among them. It's a bold vision, one that combines the cutting-edge science of genetics with the boundless possibilities of space exploration. And as we stand on the brink of these breakthroughs, one thing is clear: the future of space travel might just be written in our genes. Picture a universe where the vast majority of its contents remains invisible to us. That's the reality we live in. Dark matter makes up roughly 27% of the cosmos, yet it's something we can't see, touch, or fully understand. Now imagine if we could harness this mysterious substance as a source of energy. That's the bold vision behind dark matter propulsion, a concept that could redefine how we explore the stars. Unlike conventional fuels that rely on chemical reactions or even nuclear fusion, dark matter propulsion taps into the unseen fabric of the universe. Scientists theorize that if we could somehow interact with dark matter, it could provide an almost inexhaustible energy supply. Think about it, this is a form of energy that doesn't require mining planets or depleting resources. It's already everywhere, woven into the very structure of space itself. Of course, this technology is still in its infancy, and we're far from knowing how to manipulate dark matter. But the potential is staggering. If we could unlock its secrets, we might discover ways to generate energy on an unprecedented scale. This could propel spacecraft to speeds that make interstellar travel not just possible but practical. Suddenly, journeys to distant star systems wouldn't take generations. They could become achievable within a human lifetime. What makes dark matter propulsion so fascinating is how it sits at the intersection of science and imagination. It challenges us to rethink the laws of physics and explore uncharted territories in our understanding of the universe. And while it's easy to get caught up in the sheer scale of the idea, it's worth remembering that every groundbreaking technology, from electricity to spaceflight, started as a theoretical concept. The search for dark matter isn't just about space travel, though. It's about unraveling one of the greatest mysteries in science. What is it made of? How does it interact with the rest of the universe? Answering these questions could open doors we haven't even considered yet. Dark matter propulsion represents more than a new way to explore the stars. It's a gateway to understanding the cosmos itself. So, as we look to the future of space exploration, dark matter propulsion reminds us that the universe is full of untapped potential. It's a frontier that's waiting for us to take the first step, and who knows? That step could lead us to discoveries that change everything we thought we knew about the universe. Picture a future where humanity's reach extends far beyond Earth, not just to visit other planets, but to build entire civilizations in the vastness of space. This is the promise of Megastructures, enormous artificial constructs designed to harness energy, sustain life, or even reshape entire solar systems. Imagine a Dyson sphere, a colossal shell built around a star, capturing its energy output to power intergalactic societies. Or think of space habitats, self-contained cities orbiting planets or drifting through the void, offering a new frontier for human life. These aren't just dreams of science fiction, they're blueprints for our future, born from the audacious belief that we can engineer solutions to the greatest challenges of space exploration. Megastructures represent the ultimate fusion of human creativity and technological ambition. Take the concept of a Dyson sphere, for example. Proposed by physicist Freeman Dyson in the 1960s, the idea was to construct a vast array of solar panels or mirrors encircling a star, capturing its energy to meet the needs of an advanced civilization. While the scale of such a project is almost unimaginable, requiring materials and engineering feats far beyond our current capabilities, it's a vision that pushes us to think bigger. What if we could one day harness the energy of an entire star? What would that mean for our survival and expansion into the cosmos? Space habitats, on the other hand, offer a more immediate glimpse into the possibilities of megastructures. Imagine enormous orbital cities designed to mimic Earth's environment with artificial gravity, sustainable ecosystems, and all the comforts of home. These habitats could serve as stepping stones, allowing us to live and thrive in space while we explore distant worlds. They could also act as lifeboats, ensuring the survival of humanity in the face of planetary crises. The O'Neill cylinder, a concept developed in the 1970s, is one such design, a rotating habitat that simulates gravity through centrifugal force, creating a livable environment in the vacuum of space. What makes megastructures so compelling isn't just their scale or complexity, but what they represent about our potential as a species. They remind us that the challenges of interstellar travel, limited resources, vast distances, and hostile environments are not insurmountable. With ingenuity and collaboration, we can build solutions that seem impossible today. These projects also highlight the importance of sustainability in space exploration. A Dyson sphere, for instance, could provide virtually limitless energy, eliminating the need for fossil fuels and reducing our reliance on dwindling resources. Space habitats, meanwhile, encourage us to think about how we can live in harmony with our environment. Even in the most alien of settings, of course, the road to building megastructures is fraught with obstacles. The materials and technologies required are still in their infancy, and the sheer scale of these projects demands unprecedented levels of international cooperation. Yet, even as we grapple with these challenges, the vision of megastructures inspires us to dream bigger and aim higher. They remind us that the stars are not just a destination but a canvas, a place where humanity can build a new home, shape a new future, and leave a legacy that transcends the limits of our planet. This is the promise of megastructures, not just a leap into the unknown, but a bold step toward becoming a truly spacefaring civilization. As we reach the end of our exploration into these groundbreaking technologies, it's clear that the stars are no longer just a distant sparkle in the night sky, they're a destination within our grasp. From the revolutionary propulsion systems that could slash travel times across the galaxy to the artificial intelligence that might guide us through the unknown, each innovation represents a leap forward in our quest to explore the cosmos. These advancements aren't just scientific marvels, they're the building blocks of a future where humanity becomes an interstellar species. The challenges are immense, but so is our determination. The technologies we've discussed today aren't just about reaching new worlds, they're about redefining what's possible for our species. As we stand on the edge of this new era, the universe feels closer than ever. It's a reminder that the greatest journeys begin with a single step, or in this case, a single spark of innovation. Thanks for being part of this incredible journey into the future of space exploration. If this vision of the stars inspires you, don't forget to subscribe and share your thoughts in the comments below. Together, we can turn this dream into reality and take humanity to places we've only ever imagined.